My day-to-day life is under attack by statistics that I gotta crack. Can't forget about algebra and memorize tax, so I love
Hey guys,
this
Ms. Ring,
math
your favorite
class.
math teacher here. Let's go over lesson 8.3, analyzing population data. Our learning target, we have these standards of mathematical practice, and you can just put in here an S. Whoa, don't want that one. S for statistics, I is the inference, and C is conclusion, and this is the standard. Use data from sample survey to estimate a population mean or proportion. Develop a margin of error through use of simulation models for random sampling. So we're going to talk about a population. How can you meet the standard? Well, I can use statistics and graphs to represent and compare data. We can also describe distributions by finding their mean and standard deviation. Alright, go ahead and try this warm-up over here. And then when you're finished, go ahead and press play, and then we'll go over that together. Joseph's diet for the first 6 days of this week consisted of these daily amounts of fat: 84 grams, 57, 65, 80, 76, and 50 grams. Find the mean, median, mode, and range of the data. So the first thing I'm going to do with this one is I'm going to put my data in order. So I have 50, 57, then notice I'm putting check marks to make sure I've already noticed the data: 65, 76, 80, and 84. And let's just find the mean. So the mean is just taking the average. If I add all these numbers up, 50 plus 57 plus 65 plus 76 plus 80 plus 84. After today's lesson, you'll be able to figure this out in a different way. And there is 1, 2, 3, 4, 5, 6 numbers. So basically, this would give us 68.67, or 68 2/3 is your mean. Okay, the median refers to the middle. See if I can put that in there. That's what the median means. So you have 6 numbers. So if I put this orange dot there, you have 3 numbers to the left and 3 numbers to the right. So what you're going to have to do is find the average of those 2 numbers. That's what the median means, with an even set of numbers. Therefore, the median is equal to 65 plus 76, and you divide that by 2, you get 70.5 is your answer. And so we've done this one. Let's try the mode. The mode is what happens the most, what number appears the most. Is there any repeating numbers? There is none, so we would say no mode. Okay, and then the last one, we have the range. I guess that's the same as purple. Okay, so the range is the max minus the minimum. So the largest number, which is 84, and the minimum, which is 50. So that would be 84 minus 50, which give us a range of 34. Okay? Alright, which measure of central tendency best represents the data? Explain your reasoning. So this is actually going to be answered by today's lesson, but just to give you a graphical idea, you can make a dot plot. And if I have like the 50s, 55, 60, 65, 70, 75, 80, and 85. And so if I make a dot for each number, let's go from smallest to biggest. So I have one at 50, 57, 65, and then 80 and 84. You kind of draw your ghost or your more of the data is to the left, and one way you can look at that is your median and mean and median. So that would be the blue, this number, that's the mean, and the median. They're pretty much the same, 68 2/3 and 70.5. So the best measure of center, in this case, because it's symmetrical, which basically means it looks like a curve, a bell curve, I would probably use the you can either use the mean or the median, but the big idea is that it's already symmetrical, and because it's symmetrical, you would probably want to use, it's close, but the mean's probably the first choice and then median second if this was non-symmetrical. Non-symmetrical, use the median. Okay? Alright, let's change colors. Put a light red, pink. Suppose Joseph consumes 57 grams. So if I add this 57 grams here to my graph, now my more of my data is to this side. Without calculating, how will the mean, median, and mode of his fat intake be affected? So that pink dot here, you'll notice that it's going to take those two white lines and pull it this direction. So mean and median would decrease. Mean and median would decrease. Okay, so let me try to explain that again. If you just on the 7th day you add 57, that pink dot here, it's more towards the left, so it's going to pull the mean and median, which are not really resistant, towards that 57. And then if you well, that was my bad. The 57 should actually be right here. So then the mode would be 57 because you have two repeating numbers. Okay, so that's our warm-up. All right, let's take a look at our notes over here. And the measures of center and measures of spread or variation are often called something called descriptive statistics. To analyze data sets, we often look at their distribution. Another word for distribution is just the graph or the picture. So let me show you what that would look like. So this in our graph is this thing. Okay. All right, let's go into here. Let's go ahead and draw 3 graphs. All right. Let's go ahead and do a skewed right. So remember, like you're skiing, here is flat ground and here's your hill. And there you go. You're going skiing to the right. right? And then let's just say you are symmetrical. Well, you can go any direction, right? And then a skewed left. Kind of looks like that. Remember, you're up here and you go this way. And all the data, there's nothing to the left there. So this one would be left skewed. Okay. Let's start with skewed right. Skewed to the right is also called positively skewed. Okay, here's the big idea. The mean and median are to the right of the mode. All right, let me try to explain this. Okay, so here is the mode blue, and that's just telling us about repeated numbers. Doesn't really mean much, okay? And then the median, light blue, isn't really changed much either. But the one that was influenced the most was the mean. And this is how I'm going to try to describe it to you, okay? Let's talk about heights, okay? We take the average heights of our classroom. Most people are not that tall, but in comes Shaquille O'Neal, super tall person. This is Shaq, super big. And his average height is going to take the mean and pull it towards him. Because really what he is he's an outlier. He's like super tall. Okay? All right, let's talk about the normal or symmetric. So they call this one zero skewness. So just big idea, it's normal. And this is what you need to know. The mean is equal to the median, so it's exactly the same, and it's also equal to the mode. All of those numbers are the same. So let's go back to our color coordination on the left side, okay? The mode, the median, and the mean are exactly the same. Okay, all right, let's try it over here now with left, okay? They would call this one negatively skewed. Sorry. Negatively skewed. All right, big idea for this one is, where is the mean and median? The mean and median are to the left. See that? Left of the mode. Okay, so let's do this with colors. So here's the mode. Doesn't really change much. Shaq came into the room. The median's kind of staying right there. But in comes someone who is gifted height-wise, but not so tall. What does that do? The measure of center that is most influenced by this outlier here is the mean. It can be pulled. The numbers get pulled. Okay, another way of explaining it is the median is resistant. It's not going to get pulled so much by an outlier, someone who's super tall or super short. Okay, so that kind of shows it visually. I'm just going to do a chart on the next page. So let's go ahead and do that chart. All right, so page 2, big idea is choosing the measure of center. Okay, and the question you're going to ask is it symmetrical? Is it symmetrical? Does it look like this right there? Okay. Let's try to color code this. Like I always think of lights, like green light, yellow light. So if it is symmetrical, make a chart here. And this is called the measure of center that we would use. And over here is the spread. We actually talked about that before. Remember the jam? Okay. All right. So the measure of center you would use, if it is symmetrical, you will use the mean. And another word for the mean is kind of like back in your early days, they call that the average. The formula for that is x bar. The summation of all your numbers. So symbols are important. Summation, that's what that backwards E stands for. You just means add them all the numbers up, and then you basically divide it by n, which is the number of items in your list. Okay, this one's gonna be new to us, but we're gonna learn it later. So the best spread is the mean absolute deviation. Mr. Ring, you got to be mad. All right. Okay, what would happen though if no, it is not symmetrical? Then, okay, so if it's not symmetrical, I want you to think about this. In these three pictures, if it's not symmetrical, then you're crossing it off, then basically it's what? It means it's skewed. It's skewed. So I'm gonna write that out here, skewed. Okay, what is our measure of center? You will use the median. And then something we're gonna learn later on is called the interquartile range. And that is abbreviated by IQR. And basically, this comes from something, a future lesson, but I just want to write it here so you kind of 5-number summary. Okay, so you'll look at, just ask that question, is it symmetrical? If it is symmetrical, then you do the green light. If it's not, no way, it's skewed. No, it's not symmetrical, then you do what's in pink, okay?
All right, I wanted to add to this. The mean absolute deviation is also good when you have some, sometimes when you have some outliers, even within this. But the best one to use in the spread is the standard deviation.
we love math, every time we divide, we already know the path, then we multiply, all we gotta do is roll the die,